Okay, so these two problems were shared with you. And the first one I gave you, it was the two positive numbers. I'm sorry, no, that was the second one I gave you. The first one was gave you the polynomial. And what I want to encourage you is when you're doing these problems over here is that these are more typical of the type of problem you'd see on a standardized test. And the reason for that is they're really, they're trying to ask questions that really are asking you, do you really understand what's been presented to you? And certainly during class time, I will say this, that many students were able to answer this question, and that was good. All right. When I say many students, it was a good number. All right. But anyway, it says the polynomial, x4 minus 27x squared plus 121 can be factored. Now, by the way, it can be factored. They didn't say how it could be factored. They said it can be factored, right? Then they go on to say it can be factored in a unique way. That means there's going to be a unique factorization of the problem. And then they go on to say it's factored into a product of two quadratic polynomials with integer coefficients and a leading coefficient of 1. And then it goes on and says, what is the sum of the two polynomials? Well, if this were me doing the problem, what I would do is I would read it, I would try to know it read, and then I would go to my piece of paper and pencil, and I would try to do it, right? With the full understanding that if this question's being asked, it's doable. They're not asking me things I can't do. All right, that's something that's a given. So I'm gonna share another screen with you, and I'm gonna share a whiteboard with you. Okay, so I typed it up. Now, certainly I didn't type this up without doing the problem first. I did the problem first. And I want to point out the first thing I did doing the problem is I followed their instructions. And what did they say? They said that this polynomial could be factored uniquely into two quadratics with integer coefficients with a leading coefficient of 1. Well, these are two quadratics, leading coefficient being 1, and I'm going to say A, B, C, and D are integers. The next thing I would do, and this is what I had to do on paper, was I had to multiply it out. And if you do that, let me go through that with you. What would you get? You would get x4. Well, no surprise there. I do see x4 in the problem. Then what are you going to get? You're going to get plus cx cubed plus dx squared. All right. Now what do you do? Then I'm going to do ax. I'm using the distributive property of multiplication. You're going to get ax cubed. Then you're going to get acx squared. And then you're going to get what? You're going to get adx, right? Then what do you get? You get bx squared. And then you get bcx. And then you get bd. I want to remind you that A, B, C, and D are integers. That's a key word in the problem. All right, so I equate coefficients down. But what I mean by that, it's a no-brainer. X4 equals X4. But what do I notice is there's no cubes. So if there's no cubes, what do I know in the original problem, by the way? I know absolutely that that C plus A, write this down, that C plus A equals 0. In other words, the coefficients of these things, there's no cube in the problem, the C plus A must be 0. What else do I know? I know that D plus the AC plus the B is equal to minus 27. All right, I know that. I know this has to be the minus 27. And what else do I know? I know that AD plus BC is equal to 0. What else do I know? I know BD is equal to 121. I see that right over here. Now, by the way, certainly you might say stuff when you do problems and you type them up, do you putting all your scratch work down? Not really. But for me to put this problem down, I had to write all that stuff down. So what did I say? A plus C is 0. I got this here. What else did I say? D plus AC plus B is minus 27. I got that down. I got the AD plus BC equals 0. I have that down. And I have the BD equals 121. Now, this is where I want to be honest with you, it could be a struggle. Like, for example, trying to solve that, for all the possible solutions that could come up with could be a very difficult problem. All right. Now, remember, on a standardized test, if you're looking at this over here, they're not looking at your work on a standardized test. Your work is just scratch work over somewhere. All right. So we're looking at this over here. One thing I'd like to keep in mind is that, that all the letters A, B, C, and D are integers. So what I would say is can say, I wonder if this could be easier than it looks. So what I would look at over here, I would say, gee, A must be equal to minus C, or C is equal to minus A, depending on how I look at it. So I'm gonna write this over. A is equal to minus C, or if you prefer, you could write down C is equal to minus A. It's either or, doesn't matter. So if I took this and plug in a second equation, what do I get? I would get D plus, what would AC be? Well, AC would be minus A squared now, right? I'm doing A times C. That'd be A times minus A. So that's minus A squared. Let me just do the area shot and I'll put that down. Again, this could be a dead end. And then what do you get? Plus B is equal to minus 27. Well, at least I got one less letter in that. Now, the next thing I noticed is, I got the ADBC. Now, maybe I could use that later. I don't know. But I'm noticing the last line is BD equals 121. So what else over here? If these are integers, there are many integers you could do it. But I'm saying you could try like 1 times 121. Plus you could do minus 1 times 121, minus 121 as well. That would do it. But I'm going to say that just doesn't look right to me. So I'm going to say 11 and 11 would also give you 121. All right, now it could be minus 11, but I'm going to go easy. What I'm going to say is I would like to believe B and D are both the same number. So I'd like to believe that B and D are both 11. Now, by the way, that may be wishful thinking, but I try to do easy wishful thinking at first. Is this going to work out? Well, I'm going to take this, which is my fantasy, and plug it in up here. And what would you get? 11 minus A squared. Again, I'm plugging it in. Plus 11 equals minus 27. What does this give me? 22 minus A squared equals minus 27. Geez, this is nice. There's only one letter left. What do you get? Minus A squared equals minus 49. A squared is equal to 49. What does it mean? A could be plus or minus 7. Well, you know what? I think I'm ready to try now. And someone says, what do you mean you're ready to try? I think I'm ready to try something. Now, I'll tell you what I'm ready to try. I'm ready to try a multiplication now to see if it works out. And what's multiplication going to do? X squared. Well, I'm going to say A could be plus or minus 7. So let's put down minus 7 here. I'll just try that. I don't know. And I think B might be 11. And then it's going to be X squared. And let's see, A and C are related, right? They're opposites. So that would mean if that's true, this would be 7X now. Sorry about that. That would be 7X plus 11. Right, I'm going to multiply it out though. And what do you get? X4. It's worked though, I know that. 7X cubed. I'm multiplying by X squared, by the way. 7X cubed plus 11X squared. Now let me do the minus 7. So what do you get? Minus 7X cubed minus 49X squared minus 77X. Let's keep going. Plus 11X squared plus 77X plus 121. Again, I got to add all together. I'm hoping, I hope my try is going to work. And what do you get? You get X4, and then you get no cubes. And then what do you get? You get 22 minus 49, which is minus 27X squared. Gee, the X is here, you get plus 121. Is that what we wanted? It is. Now, by the way, if you don't remember the original question, that's too bad. What's the original question going to be? What happens if you add these two together? That was their question. Now, one student did a common error. I want to point out the common error that this one student did. She said x4. X squared plus x squared is not x4, by the way. But it's an error. I realized that she did a good job, and I asked her to correct herself. She didn't, but I gave her credit anyway. Let me go back and erase this. That's not x4. What is it? It's 2x squared. The x's disappear, and you get 22. That was their question. That would be their answer. All right. So what I'm going to do now is I'm going to stop my whiteboard, and I'm going to go back to the other share now. Okay. So we're still in this problem over here. What I decided to do is I'm saying, I'm not going to say it was a great question, but it's a question where a lot of students do struggle with it. Not everyone. By the way, I don't know how people got the answer. They may have done what I've done. They may have done something completely different. All right. Here's what I'm going to do, though. I'm going to say that you could also use SAGE. I would not recommend it because in center's exam, there is no SAGE. The problem with using SAGE, I want to go through this over here with you and, reset. I put A, B, C, D down as variables, right? And then I said solve. What I do, I did my preliminary work. I'm just typing the equations I got from the original problem, and I just typed them in there and solved for A, B, C, and D. The problem is the answer. I want to point out this is one answer, but I want to claim to you these are not integers, and at least they're not all integers. So this couldn't be the right answer. However, that's a solution to it. But they said there's a unique answer with the with integer coefficients. The next one also, this is another answer, and these are not all integer coefficients. Then I get to this one over here, and I notice these are integer coefficients, every single one. All right, the A, the B, the C, and the D. All right, this is also an integer. All right, this is going to give the same result by way of plug them in. The next one, they're not integers. The next one is not integers. All right, but there's a lot of answers over there. All right, so let me go to the next question, and that's using SAGE. I certainly get the same answer using SAGE I did by thinking about it. The problem with thinking, though, it does take time, and if you're under pressure, it may prevent you from answering the question. Not saying you're not of the quality that you can answer the question, just that people under pressure sometimes have a tough time answering questions. And certainly it happens to just about everyone when they get under pressure. Let me go to the next question, and this is the next one. And no one was able to get this one. No one, all right? Given a lot of time, they were not able to get it. So what I want to do is I want to go back to the whiteboard and I want to talk through it for you, all right? I'm not saying it's an easy question. I'm just saying you have the skill set to do it. So what I'm going to do is I'm going to go to a whiteboard. Give me a second to get back there. Okay, let me get rid of this. I'm going to start doing this problem now. And someone says, how do you do this? I definitely have to use paper and pencil to do it. It isn't like I write this stuff down without using paper and pencil. The first thing I did was I decided that they had three things down. They had, and I'll point out what they had. They had this was equal to this was equal to this. So also I said they're all the same number. I just didn't know what they were. I said they were all the same number. Then what I did was I started to rewrite these problems as a single log. Now, do I have the ability to do that? I do. I have the ability to do that. So that's the first thing I would have done. So for example, log base 2 of the number 4 is the number 2. And then I use rules of logs to write it as a single log. This is sum of 2 logs over here. And the sum of the 2 logs would be just log base 2 of 4a. And that equals x. All right. So then I wrote this over here. I just wrote this log, which is kind of foreign to me, as an exponential. That's going to be 2 to the x would equal 4a. And then I solve for a. What's a going to be? 2 to the x over 4. By the way, this could be a dead end. I'm just saying, at least I have some understanding what the a is in the problem. What is it? It's 2 to the x over 4. Right. This may or may not be useful. The next thing I did, I wrote down a piece of paper. It takes time, takes effort. There's no doubt about it. I wrote the next equation down. The next expression down, which is 3 plus log base 3 of b. And I tried to write it in terms of logs. And log base 3 of 27 is the number 3. And then I use the rules of log. What I get, log base 3 of 27b, I'm just using the rule of logs over here, is that same number x. And so what I do, I wrote this log as an exponential, and stuff that we've covered in class, by the way, 3 to the x equals 27b. All right. Then what I do, I solve for b. What's b? 3 to the x over 27. All right. So I know what that is. I got these guys over here. I got them covered. So let me point out, I've got this one covered. I've got this one covered. All right. Then I took the log base 6. Next one, I'll put over here what I've done. I've done this one over here. It's also equal to x. What does that mean? A plus b equals 6 to the x. Now, this is the part where a lot of students, myself included, might get stuck in the problem. I'm kind of looking at it. And what I notice is that, and I'll circle this for you, I'm noticing this and this look remotely like 6. So what I would do, I'd take those two, I'll write this down for you, and I'd write down a times b. And maybe it goes nowhere. But what do you get? 2 to the x over 4 times 3 to the x over 27. All right, let me keep going. And what would this give me? Well, on bottom, 4 times 27, that's 80 and 28, 108. And on top, it's really 2 times 3 to the x power, which is 6 to the x over 108. And what is that? A times b. That's all it is. By the way, it still could be a dead end, but I wrote that down over here. This is written down over here. Now let's go back to this. All right, let's write this down now. And let me go back to black. A plus b is equal 6 to the x, right? What's 6 to the x equal? It's equal 108 times AB. Where am I getting that? Right over here. All right, let me write this down. A plus B equals 108 AB. Then what would I do? Geez, what would I do? I would probably know what the question was. And what was the question? The question they had was this. What's this equal to? I don't know. Let's see if we can do it. I would divide both sides by AB. That's like dividing every term by AB. And what would you get? 1 over B plus 1 over A equals 108. That's the answer. All right. That's a tough question. By the way, some people would say, I could probably get that by luck. And here's the deal. A lot of life is luck. You're given a question, you take the right route, you get to the right answer, right? That's luck. Sometimes it's what's called dumb luck, but it's not bad to have luck on your side. Luck is going to improve when you start to practice more. Luck will improve when you practice more. In other words, you're going to start to recognize more and more techniques as you start to practice. Is this related to what we've done with logs? Yes, 100% so. All right. So let me, I'm going to stop that share. And I want to go back to Sage. Again, let me just put out what we got. We're doing this one over here now. And I'm going to Sage. But when I was doing Sage, I had to remind myself how to rewrite the log. I didn't want natural log. I want to use log any base. So I had to remind myself. And so I looked for a simple example, and that's log 9 base 3, and that should be 2. So I was pretty comfortable I got the correct form of that. For example, log, let me write this one down for you. Log of 100 base 10 should be equal to 2. All right. Log 27 base 3 should be 3. I think you get the idea that that's pretty easy to deal with that. Now, what I did though was, whoops, sorry about that. What I did was I typed in the problem and I said, could you solve it? So I typed in, basically it boils down to three different equations over here. And I think you probably can see those three equations right over here that I got. And I said solve for AB. Unfortunately, when I asked Sage to do that, Sage spits back the exact same answer to me. All right. When I said exact same answer, they did change it a little tiny bit. They rewrote it in natural logs, but it couldn't do it. All right. So it's really through some kind of manipulation that I got to the final answer on it. All right. Now, someone's going to say, could you rewrite that? Let me just do another one down here, and I'll do this over here, and solve for. I'm going to see if I can solve for this over here. 1 divided by A plus 1 divided by B. And by the way, this may throw Sage into an upsetting thing, saying I can't do that. It does. It says a type error over there. It's not iterable. It's having a tough time with it. Now, granted, could you do it in Sage? Yeah, but it may take a tremendous effort to do that, whereas doing it by hand is a lot simpler. But that shouldn't prevent you from thinking, does Sage have other routines that would allow me to solve a problem like that? And I'll be honest with you, it probably does. I'm just not familiar with Sage, all right? We're trying to encourage this, though, trying. And that's the key here. Try, try, try. If you notice, most of the questions we give you, whether they're in my notes or in WebAssign, they reflect very much the same tone that what we do in class, which is problems that are carefully written to work beautifully, right? Now, these problems are also carefully written, but they don't work beautifully. It requires thinking, and thinking is what's going to allow you to move forward academically, your ability to think and move forward, resilience, not giving up, moving forward. Thank you.